It is highly recommended to ground attic-mounted antennas. The number 17 copper-coated steel wire is an acceptable bonding method. Connect the wire securely to the antenna grounding lug. The coax shield should be grounded at the TV end using a proper grounding block or surge protector. Do not connect the coax shield directly to the antenna ground wire. The other end of the number 17 wire should be bonded to the interior copper pipe using a wire nut or copper grounding clamp. Ensure the copper pipe is grounded via a separate path to the electrical panel or grounding rod. The distance between the antenna and TV is not a factor in grounding effectiveness. Use weather-resistant materials for all connections. Maintain good electrical contact between all connections. Regularly inspect the grounding system to ensure it remains intact. Grounding an attic-mounted antenna is crucial for safety, protecting your equipment from electrical surges and static electricity. A properly grounded antenna also helps to improve signal quality by reducing interference. Firstly, let's discuss the components you will need. You'll need the number 17 copper-coated steel wire, a grounding block or surge protector for the coax cable, wire nuts or copper grounding clamps, and weather-resistant materials for outdoor connections. Secondly, you need to know how to properly connect the antenna to ground. Begin by securely attaching the number 17 wire to the antenna grounding lug. This lug is typically located on the antenna itself. Ensure the connection is tight and corrosion resistant. Thirdly, focus on the coax cable. The coax shield should be grounded at the TV end, not directly to the antenna ground wire. Use a grounding block or surge protector specifically designed for coax cables. This device will provide a safe path to ground for any surges that may travel through the cable. Fourthly, connect the other end of the number 17 wire to the interior copper pipe. Use a wire nut or copper grounding clamp to make this connection. Make sure the copper pipe is grounded via a separate path to the electrical panel or grounding rod. This ensures that the entire grounding system is effective. Fifthly, let's consider the materials. Weather-resistant materials are essential for all connections, especially those exposed to the elements. Use waterproof connectors and sealants to prevent corrosion and maintain good electrical contact. Sixthly, inspect the grounding system regularly. Check for loose connections, corrosion, and any signs of damage. A well-maintained grounding system is crucial for long-term safety and performance. Proper grounding not only protects your equipment, but also reduces the risk of electrical shock and fire hazards. It's a simple process, but it requires attention to detail and the use of appropriate materials. By following these steps, you can ensure that your attic-mounted antenna is properly grounded and safe to use. The NEC, or National Electrical Code, provides guidelines for grounding and bonding electrical systems, including antennas. While the specific requirements may vary depending on your location and the type of installation, it's always a good idea to consult the NEC or qualified electrician to ensure compliance with local codes. Grounding systems are designed to provide a low impedance path for fault currents to return to the source, typically the electrical panel. This helps to trip circuit breakers or blow fuses, interrupting the flow of electricity and preventing potential hazards. In the case of an antenna, grounding helps to dissipate static electricity and protect against lightning strikes. A lightning strike can generate massive amounts of energy, which can damage or destroy electronic equipment if not properly grounded. A properly grounded antenna can help to divert this energy safely to the ground, minimizing the risk of damage. In addition to grounding the antenna itself, it's also important to ground the coax cable. The coax shield provides a path for electrical currents to travel, and if it's not properly grounded, it can become a source of interference or even a safety hazard. As mentioned earlier, using a grounding block or surge protector at the TV end of the coax cable is a simple and effective way to ground the shield. These devices typically have a grounding lug that can be connected to a nearby ground point, such as a metal junction box or a grounding electrode. When selecting a grounding block or surge protector, make sure it's designed for use with coax cables and that it meets applicable safety standards. Look for products that are UL listed or have been tested by a recognized testing laboratory. The copper pipe that you're using as a grounding point must also be properly grounded. This typically involves connecting the pipe to the electrical panel or grounding electrode, such as a ground rod or a ground plate. The NEC specifies the size and type of grounding electrode conductors that must be used for grounding systems. These conductors must be made of copper or another approved material, and they must be sized appropriately for the size of the electrical system. When connecting the grounding electrode conductor to the copper pipe, use a copper grounding clamp that is specifically designed for this purpose. These clamps provide a secure and reliable connection that will withstand corrosion and vibration. In addition to the grounding electrode conductor, the copper pipe should also be bonded to other metal objects in the vicinity, such as water pipes and metal conduit. This helps to create an equipotential plane, which minimizes the risk of electrical shock. Bonding is the process of connecting metal objects together to create a common electrical potential. This helps to prevent voltage differences from developing between the objects, which can be a source of electrical shock. The NEC requires that all metal objects that are likely to become energized be bonded together. This includes water pipes, gas pipes, metal conduit, and metal building components. When bonding metal objects together, use bonding jumpers that are made of copper or another approved material. These jumpers should be sized appropriately for the size of the electrical system, and they should be securely connected to the metal objects using bonding clamps or other approved methods. Maintaining a good electrical connection is essential for a properly grounded antenna system. This means ensuring that all connections are tight, clean, and corrosion-free. Loose connections can create resistance, which can impede the flow of electrical current and reduce the effectiveness of the grounding system. Corrosion can also create resistance, and it can eventually lead to the failure of the connection. To prevent corrosion, use weather-resistant materials for all outdoor connections. This includes waterproof connectors, sealants, and corrosion-resistant hardware. You should also inspect the grounding system regularly to check for signs of corrosion or damage. If you find any corrosion, clean the affected area with a wire brush and apply a corrosion inhibitor. If the connection is damaged, it should be replaced immediately. Remember, grounding is not just about connecting wires to metal objects. It's about creating a comprehensive system that provides a safe and reliable path for electrical currents to flow. By following the guidelines in the NEC and using appropriate materials and methods, you can ensure that your antenna system is properly grounded and safe to use. And always consult with a qualified electrician if you have any questions or concerns. Antenna grounding and bonding practices are crucial for ensuring electrical safety and protecting electronic equipment from damage due to lightning strikes or power surges. Proper grounding provides a low impedance path for fault currents to flow back to the source, thereby minimizing the risk of electric shock and preventing equipment damage. Firstly, antennas should be grounded in accordance with the National Electrical Code, or NEC, Article 810, which provides specific requirements for grounding and bonding antenna systems. This article outlines the methods and materials that should be used to ensure a safe and effective grounding system. Secondly, the antenna mast or supporting structure should be grounded using a grounding conductor made of copper or other corrosion-resistant material. The grounding conductor should be securely connected to the mast and to a grounding electrode, such as a ground rod or a connection to the building's grounding system. Thirdly, the grounding conductor should be as short and straight as possible to minimize impedance. Sharp bends or long runs can increase impedance, which can reduce the effectiveness of the grounding system. Fourthly, the grounding electrode should be located as close as possible to the antenna mast or supporting structure. This helps to minimize the length of the grounding conductor and reduce impedance. Fifthly, all metallic components of the antenna system, including the antenna mast, supporting structure, and any metallic enclosures, should be bonded together to create a common ground potential. Bonding helps to prevent voltage differences from developing between these components, which can be a source of electric shock. Sixthly, the coax cable that connects the antenna to the receiver should also be grounded. This can be accomplished by using a grounding block or surge protector at the point where the coax cable enters the building. The grounding block or surge protector should be connected to a grounding electrode, such as a ground rod or a connection to the building's grounding system. Seventhly, the grounding electrode system should be inspected regularly to ensure that it is in good condition and that all connections are secure. Corrosion or loose connections can reduce the effectiveness of the grounding system and increase the risk of electric shock. Eighthly, it is important to use appropriate grounding hardware and connectors that are listed for the intended purpose. Using the wrong hardware or connectors can compromise the integrity of the grounding system and increase the risk of failure. Ninthly, when installing a grounding system, it is important to follow the manufacturer's instructions carefully. Failure to follow the instructions can result in an ineffective or unsafe grounding system. Tenthly, it is always a good idea to consult with a qualified electrician or antenna installer to ensure that the grounding system is installed correctly and in accordance with all applicable codes and regulations. A properly installed grounding system can provide peace of mind and protect your equipment from damage due to lightning strikes or power surges. Grounding and bonding are essential components of a safe and reliable electrical system. They help to protect people and equipment from electric shock and damage due to fault currents. Grounding provides a low impedance path for fault currents to flow back to the source, while bonding ensures that all metal objects in the vicinity are at the same electrical potential. The NEC provides detailed requirements for grounding and bonding electrical systems. These requirements are based on years of experience and research, and they are designed to ensure the safety of people and property. It is important to follow the NEC requirements carefully when installing or modifying an electrical system. The grounding electrode system is a critical component of the grounding system. It provides a connection to the RF, which helps to dissipate fault currents and prevent voltage differences from developing. The NEC specifies the types of grounding electrodes that are permitted, as well as the methods for installing them. Common grounding electrodes include ground rods, ground plates, and metal water pipes. The grounding electrode conductor connects the grounding electrode to the electrical system. The grounding electrode conductor must be sized appropriately for the size of the electrical system, and it must be made of copper or other corrosion-resistant material. The bonding jumpers connect metal objects together to create a common electrical potential. Bonding jumpers must be sized appropriately for the size of the electrical system, and they must be securely connected to the metal objects using bonding clamps or other approved methods. Surge protection devices, or SPDs, are used to protect electronic equipment from voltage surges. SPD are typically installed at the service entrance or at individual equipment locations. They work by diverting surge currents to ground, thereby preventing them from damaging the equipment. It is important to select SPD that are appropriate for the type of equipment being protected. There are different types of SPD for different applications, such as power circuits, data circuits, and communication circuits. Regular inspection and maintenance are essential for a properly functioning grounding and bonding system. Connections should be checked for corrosion and tightness, and grounding electrodes should be tested to ensure that they are providing adequate grounding. Any damaged or corroded components should be replaced immediately. In addition to the NEC requirements, there may be local codes and regulations that apply to grounding and bonding systems. It is important to check with the local authorities to ensure that the system is in compliance with all applicable codes. A qualified electrician can provide assistance with the design, installation, and maintenance of a grounding and bonding system. An electrician can also perform inspections and testing to ensure that the system is functioning properly. Remember, electrical safety is not something to be taken lightly. Grounding and bonding are essential components of a safe and reliable electrical system. By following the NEC requirements and consulting with a qualified electrician, you can help to protect yourself and your property from the hazards of electricity.